not always. Oh, I see what you're doing. Good thinking, good thinking. It may work on this one. All right, go through the routine and find the other two. Okay? Woo. Philip, how you doing?
Good.
You got that phone, put that phone away there before I checked in. Now, could we do something like this? Find the zeros, that's part of that test. I thought I'd better start out with this for a little recap, since I have not seen you guys for a while. Guys, make sense? Here? Okay, now I've got to finish up chapter 2 tonight. I'm supposed to be in chapter 3 by now. I've got to finish up chapter 2 for sure tonight, for you. I've got some handouts for you. But let's see what else I'll mention here before I jump into it. Mr. Park, how you doing?
Doing good.
Have you heard from any of those colleges yet?
No.
Here we go. Here's what the lesson's all about tonight. Guys, I'm gonna erase a little bit of this. Are we okay here? Find the zeros, find the zeros, find the zeros, where there could be an I in some of those zeros. Okay. You erase this. And let me jump on this side here. Anna, Park, before I jump into it, you can share a little short story with the class. When I make my copies, I can do it here on campus, but I usually stop at my local FedEx close by and do my copies before I travel to school. And since I go in there so many times, they know me. All I want to do is just walk in, use the copier, and leave. I'm not there to socialize. So they know me. Some of them will wave at me. How you doing, sir? I'm doing well. Have a good day. I'm just here to make copies. So I'm here long, I've been going there long enough where, and Anna, Park, you've heard this, and this happened just recently again. They have a lot of students working there. Little part-time jobs, which is good for students. They're working there. So this one guy, the machine, sometimes the machine, so he had to come over and check the machine out. I said, I don't want to open the machine up, I may mess it up. Could you help me? So he came over and helped me. So we get the machine working. And he saw my papers. He said, you're a math teacher? I said, yeah. I said, where, are you taking a math class? He said, yeah, I'm kidding. Oh, yeah, I'm taking a math class. I said, where? He named the particular college. I said, oh, you're at the wrong college to begin with. I said, you're at the wrong college. He goes, that's okay, but you're taking the class. Yeah. So I said goodbye and left, and sure enough, when I went in the next time, he was working. So the machine was not broken. I was good. I was making my copies. I saw him coming over. I go, oh, he just wants to chat. Don't just chat with him. No, he has algebra book with him. He says, could you help me with some problems? I said, which class are you taking? This is just a basic algebra class he's taking. So he's having difficulty. I said, well, I'm rushed, you know, I'm making copies here. I'm rushed, and I've got to get to work. I said, but here, give me your book. So I looked at it as we're standing there, the copier, looking at it. And he showed me what he needed done. I said, here, try this and try that. And then he smiled. He said, oh, I got it. I said, well, I said, you know what you did? Interrupt me. You know, I was busy here. I said, who's going to pay for these copies? So again, this looked like, because if you work there, I'm sure he gets a discount of some sort. I said, could you use whatever allowance they give you to help pay for these copies? Because I helped you. Okay. So now when I go in next time, I haven't seen him for a while. He may stay away from me. But he brought his book there. I thought that was cute. He brought his book in since I was a math professor and asked me to help him a little bit here, guys. It wasn't anything like this. They were not doing stuff like this. Okay, on the next part here, let's call it part 2, I guess. Let me do this. You'll see what class is all gonna be about tonight. I have a question for you. Suppose it was phrased like this: find the complex zeros of this. And I have it written as f of x is equal to this x squared minus 8x minus 4. And for some reason on the side here, I use a different color. I have this function, g of x, written like this. X subtract 4 squared, subtract 10, we step back, look at it, think about it. I may have something there written down wrong, minus 20. Then we step back and look at it, make sure everything's looking good. Everything's looking good now. Please tell me. Let me get just some input from you guys. If you're asked to find the zeros, this is a nice little quadratic. That's all it is. 2 zeros. Can anyone tell me what you might want to use in an attempt to find the 2 zeros on this first function? You see that staring at you on the test. And it says find the zeros, find the complex zeros. What would you attempt to do if you want to take this right here and do it? Give me an idea. I think you know what to do. What might I do here? Is it a quadratic to begin with? No U substitution needed here. Jump right into the quadratic formula. Guys, look at this. X is equal to, it's a negative b, so let's turn this into an 8. Plus minus square root 64b squared, subtract 4 times 1 times c. I have to be careful myself putting all these numbers in, all over 2. Wow. I think we agree with that, I hope. So x is equal to 8 plus minus square root. Underneath that square root, guys, help me out here if I have no mistake. Please do it. I hope we don't have a mistake. Did I put all my numbers in correctly? I think I did. So what is that? Is that 64 plus 16? Is that 64 plus 16? Underneath there, I think it is. Which is 80? All over 2. Interesting. This is a simple quadratic. Find zeros. 80 is not a nice perfect square root, but can be broken down. Anyone know what the square root 80, by the way, there are no i's in this one. What does square root 80 look like simplified? If you can simplify it. It's not perfect. It's not 8. I wish it were 81. It's not 81. It's 80. So you're trying to break down square root 80 if you can break it down. Can you? What's a good choice to get started? Give me a choice for 80. In an attempt to break it down. What times what is 80 in hopes of it'll break down? Some students may start out with, Professor, my goodness, 4 times 20, that's 80. I agree. And square root 4 is nice, that's 2, but you're still left with square root 20, which is not perfect. It can be broken down again. What's a choice for 20? You may say, well, think of 20 as 4 times 5. Look at this process. And then, of course, that's going to give you 2 radical 5 just for the square root of 20. Plus, you have this 2 out front, and therefore you're going to end up with altogether 4 radical 5. Do we agree? Can anyone think of a choice that would have gotten me to 4 radical 5 a little bit faster? Is there another choice for 80 besides I started with 4 times 20? Was there another choice that you could have used that may have gotten you down here a little bit faster for 80? How about 16 times 5? If I had used 16 times 5, that would save me a little work, but you do whatever you want to do there to get this into the form I want. So So guys, going back, this is 4 radical 5. All over 2. Simplify it by dividing everything by 2, reducing this down by 2. I'm going to end up with x is equal to 4 plus minus 2 radical 5. And it looks like the 2 on the bottom becomes a 1, which is cute. It looks like reduced down by 2. It looks like that if we agree. So those are my zeros. Took a little time. And use quadratic formula. Please tell me. Now let's go to the red one. I want to solve it. Find the zeros, which means you're going to do this. Now give me an attempt. What would you try as a student to solve the red one? The way the red one looks, the way it's presented to you, what would you attempt to do to solve it? Anyone?
Quadratic formula.
I can't use quadratic formula. It's not quadratic right now. You could expand this thing out. You could. After that will work. Give me a faster way. The way is presented to you. What's a faster way to solve the red one? Without expanding that out. Yes. Move that 20 over. Oh, look at that. Move that 20 over. And then do a square root on both sides. So guys, we're going to end up with x subtract 4, of course, here. And I ain't going to put plus minus because you expect 2 answers here. It's quadratic. 20, not a nice perfect number, but square root 20 broken down, 4 times 5 gives me 2 radical 5. Is that true? And then solve for x, move the 4 over. If I move the 4 over, guys, that does not say 4 plus 2, I can't call it 6. It looks like this when I move the 4 over. Be careful. And I get those answers. Are those the same answers I got for the other function? I got these for this f of x. Then the red g of x function, I got the same answers. Which one do you think would be easier to give to you on the exam to solve? If I ask you, or if I ask for a question like this, which one would you prefer Ramsey to place on the test to solve? Which one's going to probably take less time? Is it going to be this one? Or this one? I think this one's less time. I think the second one's less time to do and get the answer done fairly quickly. Now, here's what the lesson's all about down to close down chapter 2. Coming down to this. Guys, the purpose of this in chapter 2 is, can I, with your help, take this, if I wish, at the very beginning, initially, can I take what's given to me and change it to this right quickly? If I can, then I'll solve it in this form. It's called completion of the square. This is what it's coming down to. Completion of the square. Wow. Now here's why they call it completion of the square. Can you take this, a big of a deal like this, can you take this and rewrite it with a square? So they're called completion of the square. Now, I need some hints on how to do this. Got a nice little handout here. Guys, I've got a few items to look at underneath here for some examples, just to look at. I brought this in. I know, and you know, that if I solve this expression, it will factor into, in no time, that. Is that true, guys? Is it a factor? Are those two sides the same? If I solve this, another one here, y squared plus 4y plus 4. I don't think you can argue with this. That can be written as this. Y plus 2 squared. And it looks like I may have thrown another one in. I did. Number 3. K squared plus 10k plus 25 can be written real quickly as k plus 5 squared. Yeah, I did throw one more in. 4a squared, subtract 12a plus 9. Can anyone tell me what 4a squared minus 12a plus 9 can be expressed as based on the others you've seen on the board? Can it be written like this? And maybe not. Can it be written as a perfect square? And you'll see where I'm going with this completion of the square topic tonight. Anyone tell me 4a squared minus 12a plus 9 right quickly is equivalent to, if it can be, what nice perfect square would correspond to this one? Anyone have a guess? 2a minus 3. 2a minus 3. So there's something going on with this. If I can recognize what's going on before I get into my issue here, in chapter 2. Guys, on the side here, I need some input from you. I'll sort of guide you through this. Let's see if I'm doing this. Okay. This cannot be x subtract 3 squared. If I look at the left-hand side, the original, one observation, this is me looking at, is this number right here, half of this. It's half of 6, 3. Down here, on this one, half of 4 plus 2. Down here, half of 10 was 5. Is that an observation? Now, when I get down to the last one, I threw that last one in for a reason. Half of 12 here is supposed to be 6. Did you see a 6 over here? So that last one sort of messed me up. The other 3 are good. I see a relationship going on. Half of this, half of 6, 3, negative 6. Negative 3 squared, there's negative 3. Half of 4, 2. Half of 10, 5. So I see a relationship. Also, I see another relationship. What's that? Does anyone observe anything else besides that little 1/2 business? How about the 9, the 4, the 25? Is that merely those numbers on the end? Corresponding with this is what? 3 squared is what? 9. 2 squared is 4, corresponds. 5 squared is 25. Is that true? But if I try it down here, it's not going to work on this one. So something threw this one off. These right here will be the topic I'm going to concern myself with before I reach this strange one. Anyone tell me what might be happening on the last one that was not happening on the other 3? It's going to make the other 3 so much easier. What's the difference? Why is the 4th one not going to work out the same with those little tricks as the other 3? What difference is it? This is beautiful. This is beautiful. This is beautiful. No. What's happening here? What made the difference? Does anyone see the difference? In the first 3 compared to the 4th one?
The number out in front?
Do it again.
The number out in
That,
front?
they call it leading coefficient. The number stuck out front has to be a 1. If you expect these little tricks, these little strategies to work, this coefficient must be a 1. And then you can play around with it to make it work. Okay, so that's one observation right there. Now that said, let me do this if I can. In fact, let's see if I'm ready for the handout here soon. Oh, look at this. Let's see if I'm ready. Okay, I don't want to scare you. The other side here, where I give you the handout. suppose you solve this. Y is equal to, I brought this in, x squared, subtract 8x, subtract 4. I would like to rewrite it as a square. Bring a square in like this, that square, this square, this square. I like for that to happen here. Now, can anyone tell me a clever way to maybe take that, rewrite it in a form like this, with a square in it, for a reason? Yes,
We just did this one, I thought.
come again.
Didn't we just do this one?
X squared subtract 8x minus 4.
Because it would be rewritten as g of x over there.
Okay, got you. Right here now. Tell me first though, what you're thinking of. These two terms here, focus on these two. Anyone tell me what would I have to add to that, the way it looks, to get a nice perfect square, something like these? What would have to be placed on the end, and then I'll do it, I'll factor it, and it should be a nice perfect square. What do you think goes on the end here? X squared subtract 8x plus, I'm doing it like this,
16.
look at that. That's why they say, call this completion of squares, you're completing, you gotta add something to it. Is it 16? Watch carefully. Will that much right there factor into a nice perfect square, something like these? This will quickly factor into, if I wish, x minus 4 squared. Yes or no? Here's the catch. Can I stop here? Was this the original function I had to work with? It's not the original. I'm playing around with it. It's not the original function. Just wait, Professor. There was no 16 back in your original function. You put that in to complete it. Completion squared. There's no 16. So let's do this right quickly and make that 16 disappear. What was on the end? Minus 4. Do this, put it in a different color here. Minus 4 was on the end of the original. Now guys, please tell me, at this point, is all this mess, where I made these 16s cancel, would all these simplify and give me the original function I had? Will these 16s cancel? And give me x squared minus 8x, and of course on the end I had minus 4. Will that now rename what I had? With that said, I've got now x minus 4 squared. Beautiful. Guys, is this what, minus 20? Does I have to do this? Yes? No?
Yes.
Now, is this and this, with all my work, are they equivalent? And I had to do something called completion of the square. I had to make a square come in there. Now, if I ask you to solve it, I think this is what my students tell me. You say, Professor, ask me to find the zeros, there's no problem here. Just set this equal to 0. Move that 20 over. Do a square root on each side. No problem. And you end up with x subtract 4 is equal to plus minus. You expect 2 answers. 20 is not perfect. Can be simplified though. 2 radical 5. Move that 4 over to solve for x. And if there's no mistake, those are the zeros for this. Now they did not touch quadratic formula. If you did by quadratic formula, you should get the same answers, if we have no mistake. As it's called completion of the square. Because the professor, where are you going with this? Here's where I'm going. Close down chapter 2 and the handout coming up. I got what time here? Beautiful. Right where I should be. You guys hang on. Here we go. Try one more here. But y is equal to 4x squared minus x plus 1. Oh, this one's cute. 4x squared minus 4x plus 1. I like to rewrite it, and the same thing you see right now, but rewritten in a different form. And I like to complete the square to do it. Now, can anyone tell me what might be the difference in me trying it on this one, completion of the square, and trying to completion of the square on this one, which I think we saw was an issue back here somewhere. What's the issue with this one? The leading coefficient is not a 1. It is in this case a what? 4. So that means if you want to do completion of the square, you had better first on this one, which I did not have to worry about on this one, you had better first, guys, take that 4 out. It's on the axis. I normally end up with a strange number here. And try to complete the square. Of course, I still got the +1 down here. I factor out a 4 on those x's to try to give me now a leading coefficient of 1. Now, I have a leading coefficient. I have a leading coefficient of 1 now, which I can now work with. We step back, look at it, and I think we're good. Now, can anyone tell me? Please be careful. You guys give me a 16 real quickly here on this one. You said, Professor, it's going to take a 16 to make it a square. Can anyone tell me, be careful, what do you think it's going to take on this one to make it work out? Got a fraction this time, a little tougher. But give me a guess. What do you think it's going to take right here? So when I now factor this, I get a nice perfect square like we were talking about over here. And I want to tell you what's going to take right there. And by the way, guys, you guys who got 16 real quickly, did you guys have something in mind to get to 16 on this one? Or just guess? Or did you do something in your head there to get to 16 real quickly right there, which it took? Is there a way to find it? If it's a little bit tougher? Suppose I take 1/2 of the number there. What's 1/2 of 8? Or -8. -4? And then square. Do I get that? I take 1/2 of this coefficient and then square it. Do I get 16? Does that now go in line with this 1/2 business we were talking about over here? We're doing some observations here. Divide by 2 or take 1/2. If that's true, guys, be careful. What's 1/2 of 1/4? Over here it's easy. 1/2 of 8 is 4. And you square it. What's 1/2 of 1/4? 1/8. If you square 1/8, which I need for that blank, it's not a nice number, but there is a number. What is 1/8 squared? 1 over what? 64. Not a nice number like this. We'll take 1 over 64. So if you run to one that's tougher, you've got to take 1/2 of this number, 1/2 of 1/4, and then square that result, which is 1/8 squared. Over here, 1/2 of 8, 4 squared. That's how I got the 16. The students get it 16 to me fairly quickly. Now, I got to be very, very, very careful here. Here's the original. I'm trying to rewrite the original. You don't have the original, but rewritten in a different form, different name. Guys, at this point, we check my work here. I got 4x squared minus x plus 1/16. I use the discernment property at this point. 4x squared minus 4's cancel 1x, minus 1x, and then 4 times 1 over 64 would be 1 over 16. And then, of course, I still got my plus 1. Now, here's the original. I've got to keep the original. Am I pretty close to the original here? Or should I do something to modify it to go back to and keep the original? Anyone tell me what might I do at this point? You say, wait, Professor, that number was not in the original, so you better get rid of it. Anyone tell me what I might do to rewrite this and have this? And by the way, guys, when we do this, this checks. This checks. This checks. Was there a 1 over 16 in the original? So what am I going to do? Do this first. Let's go back here. I'm going to do it up here. Let's quickly say, you had better subtract that 1 over 16. Get rid of it. And then, of course, the plus 1 is still there. Now, let's see now if it makes sense to us. This completion of the square will drive you nuts at times. Erase this, guys. We do a little factoring. This is y is equal to 4. Inside there should be x subtract 1/8 squared, which I want. And then, of course, these two put together, -1/16 plus one, it's like a -1/16 plus 16/16, will give me 15/16. Do not let me make a mistake this time. Wow. I guarantee you, and I'm gonna check here, I guarantee you, Anna, Park, if I saw students in these high-level math classes, and I asked Park or Anna, I said, Anna, what's this equivalent to? Do you think she and Park or any professor real quickly and say, oh, it's equivalent to this? You're saying this, just in a different form. Look how different they look. This and this are saying the same thing. Saying the same thing. Which one looks cleaner? I would think this one looks cleaner. This thing has fractions in it. And I said, Professor, why on earth would you like to take this cleaner one I'm so accustomed to from middle school? How would you want to mess it up and make it look like this? All right, guys, do we agree? Is this equivalent to the original? After I do that completion of the square, let me just check it right quick to make sure, because I can't go any further if it's not equivalent. To make sure it's equivalent, just we'll check 4 times, I'll expand that thing out, which I think we know what it is. It's x squared minus 1/4 x plus 1/64. And of course, I got 15/16 on the end. Who knows, man, I'd be messed up. I expand this thing out, x minus 1/8 times x minus 1/8, fractions. Careful there, distributive property, distribute to 4x squared. Thinking this, when I reach this middle term, the 4's will cancel, minus x. When I reach my last term, 1/64 times 4, it's like saying this. You cancel 4 and 64 and it's 16. That's a 1/16. Then of course I got the 15/16 on the end. Well, those two right there add up to a 1. 1/16 plus 15/16 is 16/16, which is 1. So is this now equivalent to this? Who on earth would think, Professor, why are you doing this to us? Please keep this. Like they're doing across the street. I don't think these kids across the street are doing this. But these two are equivalent. So what's the benefit in taking the blue one, what will I call it is there, take this clean one, what's the benefit in changing it into the red one? I'm saying it's the same as this. What is the benefit? Now here we go, before we take a break here shortly. Beautiful, beautiful, beautiful. Here we go. I doubt I do it all right now. I'm back after the break. Suppose you're asked to do this. Sketch this function. Here's my function. This. I like to see a sketch of it. What should you sketch into? A parabola. All quadratic sketch into a parabola. Is that true? Now, should that parabola open up or down? When I sketch it, it should be opening what? Up. Why? Because its leading coefficient is bigger than 0. It's positive. So we're open up. If it opens up, this thing has something called a vertex, a turning point. There's a turning point there. And for us in Math 2, it's a minimum. This thing has a minimum value. I'd like to know what is that minimum value. Now, so to sketch it, guys, here it is. You graph into a parabola, opening up with a vertex, and the vertex in this case is going to give me a minimum value. We'll call it local, absolute, if it's an absolute minimum value. Now, I like to sketch it after the break. discuss it right now. Now, would you prefer, here it is, I want to sketch it. I'd like to know, does anyone in this class, can you tell me where that vertex precisely would be located if I were to go to a grid and sketch this quadratic? Can anyone tell me the coordinates? The exact coordinates, the X and Y. Where is that vertex minimum located here? And if you can tell me that, I am so happy you watch what I'm doing here.
1/8.
Go. Go ahead. You're getting close. You're getting close. Look at it closely. Oh, you're getting close. Can anyone tell me right now, if you've been watching and seeing what the observation is here, can you tell me right now precisely, with numbers, where is that minimum value located, the vertex, the turn point? Right now, no effort needed.
1/8, 15/16.
Okay, hang on now. I'm here 1/8. And you're telling me the other one's what, the Y coordinate?
15/16.
15/16. Is that true? 1/8 and 15/16. Where on earth did those numbers come from? Did those numbers come from, here's the problem. This is what's gonna be written when you see this tested. I'm gonna write like this. I'm gonna ask you, please tell me, name the coordinates of the vertex. And she, who gave me the answer? Yes. Guys, she gave me this. Does anyone see a 1/8 up here? Does anyone see a 15/16 up here? No. Michael, what must I do? I must change this into this form to get those numbers she gave me. And by the way, if you were to sketch it, we're not going to sketch a full graph here for the break. Can anyone tell me, does this right here mean that's supposed to be a horizontal shift to the right 1/8? What's written? Does that X minus 1/8 means you're going to horizontally shift it to the right 1/8? And then this number tells you a vertical shift, what? Up 15/16. Would that give me what she gave me right here? You move number 1/8 to the right and up 15/16. Now, if you, as a student in college, don't get a little thrill, and many students do not get thrilled out of math, but if you don't get a little thrill to say, Professor, are you kidding? So here, I have to do this first, Professor, or I will not be able to answer with the shifts where that vertex is located. Yes, you got put in that form over there. And that's where a handout's gonna come up. Okay? So that's the vertex, that's my turning point. Now, before you take a break, can anyone tell me, I have, let me do a quick count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 2, I got 4 out today. Okay. Okay, let's say I've got 25 students. And I start with student number 1 over there, and I say, please, at your choice, it's your choice, please replace x in 4x squared minus x plus 1. Now listen carefully before we take a break. My student number 1, take a number of your choice. In fact, I probably would ask you to start with 1, and ask her to please put 1 in, crunch it out, and tell me what you get for an answer, and she'll give me the answer. Then I go to my student number 2 and say, ask my student number 2 back there to put in 2. Replace x by 2, right here, crunch it out, and give me an answer. Then I go all the way through. By the time I get to Anna back there, let's say Anna is number 25. I say, Anna, I know 25 is a large number to work with, but would you please do it for me? Replace x by 25, 25, crunch it out, Anna, and tell me what you get. And then I collect all 25 answers. And I start going through them real quickly. And all of a sudden, I see one answer of the 25 on someone's paper that looks like this. Now, hang on just 1 second. I don't want to mess this up. I see someone got 0. I don't know what number they plugged in, but they got 0. numbers are out there in the universe? Infinite. I did 25. I can start with my student number 1 now and say, now would you please put in 26? Student number 2 back there, put in 27. We're gonna go through it again, and again, and again, and again. Then all of a sudden, I collect, and some student says, Professor, the number I put in, you said, my choice, I put a number in. I got 0 to come out. Is that possible? Or did the student make a mistake? Is it possible, when I collect them, that student did put in something, they crunched it out, and they got 0 for an answer? Impossible. Not possible. Not possible. Then all of a sudden, I check through more, and I say, oh, geez, I've been bragging on this class. And all of a sudden, I see a student says, Professor, I put my number in, and I crunched it out, and I got this for an answer. How would I know? Nothing. You could not have gotten that number. You made a mistake in crunching the number. You could not have gotten a -2 for an answer. Couldn't have. Now see another paper, when I check it, they say, Professor, I got this. I got a 5 when I crunched my number out, Professor. Do you think I would accept 5? Do you think 5 would be possible? Whatever number they put in and crunch it out, they might get a 5 for an answer? Guys, yes, no? Now, can anyone tell me how would I, as an instructor, quickly go through my 25, 50 answers and rule out quickly? No, that cannot work. That cannot work. You could not get a 0. You could not get a -2. A 5, yeah, it's possible to get a 5. Why? Before we take a break. Why? What on the board tells me I cannot accept a 0 coming out for an answer.
There's no X intercepts.
That's something else. It's staring right there at you. You cannot get a 0. You cannot get a -2. You could get a 5. When you put your number in, go for it.
A is greater than 0.
There again.
A is greater than 0.
Oh, something else. Something else. I see what you're thinking of. Yes.
Is it because your vertex, your minimum point is,
There again.
your minimum point is
Whoa, 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 whoa. He said, Professor, when you graph this parabola, you've already identified to us by looking over here that the lowest it goes down to is 15/16. You go out 1/8 and down 15/16. Is this true, guys? Does it go any lower than 15/16? Well, how on earth are you gonna get that? That's lower. That's not on the graph. Is it? Is that on the graph? Is that number on the graph? The lowest you can get is, beautifully said, the lowest value you can get is 15/16. Could you get a 5? Yes. But you can't get anything below 15/16. So no, I don't care what number you put in, you'll never get a 0. You'll never get a -2. Sit there through the rest of your days. You'll never get a -2. 15/16, I think it's 15/16, wasn't it? Yeah, 15/16, well said, is my minimum. And the parabola shows that. And the work here shows that. And I've got a nice little handout to do all this in closing down chapter 2 here shortly. Guys, you got 10 minutes? Take a break. Do we have a quiz tonight? We don't have a quiz tonight, do we? Oh.